Hi, welcome back to another episode of Algebra in Words, the video series for YouTube. In this episode, we're going to continue from our discussion on linear equations and look at the next thing, which is systems of two linear inequalities. Before we get started, in case you want to read along in the written form of what we're going to discuss today, you can follow it along in my book, Algebra in Words 2, which is more geared towards Algebra 2 and intermediate algebra, kind of a little more advanced than Algebra in Words, the first one. And the topics we're going to discuss can be found on page 33 and 36. I'm going to give an overview of what systems of two linear inequalities are and an overview of how to solve them. Now, part of it is graphing linear inequalities by themselves. That part you can follow along on page 33 in my book, Algebra in Words 2. But if you want to look at the procedure for solving a system of two linear inequalities, that part is found on page 36. They're very related, and the procedure uses graphing linear inequalities. So first, let me tie together and bridge systems of two linear equations with system of two linear inequalities. Now, if you remember, for a system of two linear equations, the solution to that is one point. The point of intersection, the point where the two lines cross. That's, of course, if the lines have a solution. There's a chance they have no solution if they're parallel, and there's a chance they have infinite solutions if they overlap. I discussed that in a previous video. But again, generally speaking, if the two lines intersect in a system of two linear equations, the answer is one point. But that's going to be different for a system of two linear inequalities. For a system of two linear inequalities, the solution is the region on the graph of where the two graphs' shaded regions overlap. So to kind of summarize that, the solution to a system of two linear inequalities is the overlapping shaded region on the graph. Now, what we're going to do here is, I have a sample problem up, which we're going to do shortly. You could have two inequalities, which are here. Okay, and in this video, we're going to look at two inequalities. In a few later videos, I'll go over a system where we have more than two, maybe three, maybe even up to five. It could be as many as you want. But again, the point is, no matter how many linear inequalities there are on the same graph, the solution is the overlapping shaded region. Now, of course, it could be possible that when the two graphs are graphed on the same graph, they don't have an overlapping shaded region, and in that case, you could also have no solution. I'll make sure that we see an example where we see that as well. Now, before we get to solving, I want to just give, now that we know what the solutions are, let me give a brief procedural overview of the steps that we use to solve a system of two linear inequalities. And it's pretty easy, but there can be a few steps, and you just have to make sure that you know how to do all the steps and that you do them correctly. So first thing is I want to make sure that everybody knows the inequality symbols. This is greater than, this is less than. You always read them from left to right. So the greater side, the wider side of this inequality symbol is open on the left towards the right. So this is greater than, this is less than. And there can also be greater than or equal to, less than or equal to. When it has the or equal to line below, I refer to those inequalities as inclusive. And I'm not going to go into that too much here, except to remind you that an inclusive inequality symbol means that part of the solution can rest on, in this case, the line. All right? And when we graph inclusive inequalities, we graph those lines as a solid line, as opposed to non-inclusive inequality symbols, which these are. They don't have the or equal to line below. They just sort of stand alone. So we would say that greater than or less than. These are non-inclusive inequality symbols because if we have a line, part of the solution will not include all the points on that line. Okay, we could say that the solution or the region of solutions approaches but never touches the line. We could also, it's also said that it infinitely approaches it. So if you approached it by a fraction and then a fraction of that and a fraction of that, it will never touch it, but it gets infinitely closer. But long story short, for inclusive inequality symbols, we graph a solid line. And for non-inclusive inequality signs, we graph them as a dotted line. Very important that you remember to do that because that can make or break whether you get full credit on a problem. I'll show you that when we graph. Now, the first thing that you want to do for solving a system of two linear inequalities is you want to take the original inequalities and convert them into equations. What does that mean? Simple. It means taking the inequality symbols and switching them with equal signs. So what was originally an inequality statement, when you switch the inequality symbols with equals, it becomes an equation. Once you convert the inequality to an equation, the next step is to graph both lines. You want to do that, make sure that you do that separately, and there's two ways that you can do it. You can either make a table of 3 points. In the one of my previous videos, I call that the 0, 0, 1 method, and you graph the line with a table of at least 3 points. And the other method is to convert, once they're equations, convert the equations into slope-intercept form and just start with the y-intercept, plot that, use the slope to ultimately plot new points, then graph the line. So to summarize that first step, you take the inequality symbols, convert them into equations, and then you graph them by however method you choose to do. You graph them both on the same line. Once you have them graphed, the next step is to determine a test point. Now, a test point cannot be on either of the two lines. The test point that I often recommend to you and to my students is 0, 0. Why? Basically because it's the easiest. And in the next step, after you determine a test point, the next step is to take the values of that test point for x and y and substitute those values into each of the original inequalities. And when you do that, simplify them down as much as possible, and you're going to get from each inequality a simple inequality statement. And once it's simplified, you're going to then read it and determine if that final inequality statement is true or false. If it's true, that means that for that inequality, you're going to shade the region of the graph that's on the side of the test point. If the inequality comes out false, you're going to shade the opposite side of that test point. And when we do an example, I'll show you all that. But to get back to the test point, you always want to make sure that you choose a test point that is not on either line. If you do that, it won't work. I recommended 0, 0. But what happens if, say, one of the lines goes right through the origin, 0, 0? Well, then in that case, just choose another point. It could be 1, 0, it could be 0, 1, it could be anything. I usually default to 0, 0 because it's easiest to simplify an inequality when you just put zeros in, because almost everything reduces to 0. That's why I recommend that. In my videos, I'll choose 0, 0, and if we get a chance, we'll look at one where we choose another point. So that's the overview. And remember, once we do all those steps, we convert the inequalities to equations, we plot both lines, we use a test point, substitute it back into the inequalities, shade the regions in regards to both lines, and then finally, you just simply look for the overlapping shaded region. And if you can find it, if you shade it the way that I do it, it'll look like a crisscross. That's your solution. So anyway, let's take a look at the problem I have on the board, and let's get started with an actual example. So if you notice, I'll erase those. If you notice, I have two inequalities and two variables up on the board. The first one and the second one. Let's do the first step, which is just simply make them equations by putting in equals for the inequality symbol. So for this one, it's going to be x plus y equals 2. And for this one, I'm just going to leave a little space. It's going to be x minus y equals 2. So we did the first step. We converted them to equations. The next step is going to be to graph each one. And a sort of sub-step to that is to convert these equations into slope-intercept form. Let's do that to the top one. Slope-intercept form would mean y is by itself on the left, so I'm going to subtract x from both sides. And when we do that, we're going to get y equals negative x plus 2. And I'm just going to put a box on that to highlight it. That's not the answer yet, but just so we can see it. And let's do the same thing to the bottom equation. We want to get y alone and put it into slope-intercept form. Let's subtract x from both sides. It becomes negative y equals negative x plus 2. We want to get rid of the negative in front of the y, so let's divide all terms by negative 1. And that's going to result as y equals positive x minus 2. And put a box around that. Okay, so that step is done. Now we're going to graph each line. So I'm going to graph them over here. Make a graph. And starting with this one, start by plotting the y-intercept. That's 2, so we're going to go up 2 units. And starting here, use the slope, which is negative 1, or you can think of it as negative 1 over positive 1. So starting here, we're going to go down 1 to the right 1, put a point. Down 1 to the right 1, put a point. And going back to the y-intercept, let's also go in the opposite direction. Instead of going down 1 to the right 1, let's go up 1, left 1, and up 1, left 1. And now we have a bunch of points. I'll draw the line through that. Before we go on to graphing the next line, let's look back at the inequality. It's greater than. It's a non-inclusive symbol. So I'm going to just make this a dotted line. Hopefully you can see that that's a dotted line. Alright, I'm going to switch marker colors so that we can see the other equation graph. The other equation is y equals x minus 2. So we're going to plot the minus 2, down 1, 2. That's the y-intercept. And in this case, the slope is positive 1 over 1. So we're going to go up 1 to the right 1. Up 1 to the right 1. Up 1 to the right 1. And we have a bunch of points. Let's graph that. Again, this is a non-inclusive symbol, so we're going to make that a dotted line. Hopefully you can see that that's now a dotted line. Okay, next is to determine a test point so that we can proceed to shape. And we're going to go back to this one. We're going to start at the top. Now, what test point should you choose? And I said, try to choose 0, 0, but let's make sure that 0, 0 is not on either of the two lines. So 0, 0 would be here, and clearly that's not on either line, because here's a line, there's a line. 0, 0 doesn't touch either of those lines. So we're going to use test point 0, 0. And all we have to do is take those values, x and y, and put them into the original inequality. Make sure it's the original inequality, not the equation, because it won't work out the same. It has to be the original inequality. So x for 0 goes in here. 0 for x. This 0 for y goes here. greater than 2. Forgot to make that 0. 0 plus 0 is 0. And then we have our simple inequality. Let's test to see if it's true. Ask ourselves, is 0 greater than 2? No, I would call that false. So now, what does false mean? It means if this is our test point and this is our line, we're going to shade the opposite side. So looking at this line, the opposite side of the test point is over here. So I'm going to just draw shaded lines over here. And now let's go to the other inequality. I'm just going to switch colors. And again, we're using the same test point, but now for this inequality. So again, 0 goes in for this x, 0. 0 goes in for this y, minus 0 is less than 2. 0 is less than 2. That's what we get. And let's read it and ask ourselves if it's true. Is 0 less than 2? Yes, it is. I call that true. When the inequality is true, what does that mean with regards to the line with its related graph? We're going to shade the side with the test point. So that would be over here, and I'm going to just draw lines to show that this side is shaded. Okay, I think that's good enough. We're almost done. And now that our graph is made, our lines are shaded, we used our test points to show the proper shading of the graph. All we have to do now is look at the graph and analyze it. We're looking for the overlapping shaded region. Notice that that overlapping shaded region would be right in here, because this is where the brown lines shaded are and the red lines are. And they both crisscross. That's the shaded region. So if I highlighted that just sort of like this, maybe like this, just to accentuate that that is the shaded region that overlaps. That's the solution to the problem. This whole thing. It's the overlapping shaded region, it's the dotted lines of both lines, and really that entire thing is the solution, alright? On a test or on a question, when you're being graded, just make extra sure so that your grader and your teacher can see that you know that this is the overlapping shaded region. Just make sure that you make that blatantly obvious, draw an arrow there, or just make sure you extra highlight it. And also, make sure that your teacher knows that you made either a solid line or a dotted line accordingly for inclusive or non-inclusive symbols. Again, in this case, this was non-inclusive, so these are dotted lines for both. I'm going to stop this video and we'll go over a few more examples in the next video. But anyway, I wanted to thank you for watching. Hopefully you found this helpful. If you did, please give a thumbs up. Please share with your friends. Please subscribe to the channel so you can be aware of future videos. And feel free to leave any comments. I'll be putting other videos not only on YouTube for this, but also for Facebook and Instagram. And I'll see you in the next video.